Caleb, go back.
Alright, my people that are just joining us because you were gone today, we kind of forgot to be recording. So let me show you the pages that we've already done. We just finished up a couple examples from law of cosines. As I show you the page, I would just pause it if I were you, get it in your notes, and then we're coming right back to this last page, solving for area. Thank Ricky later because he's the one that said, hey, you should be recording. We finished this example. We started it on Friday, so we just had to finish the last couple calculations. Pause if you need it. Then we went on to this other example, side, side, side. Nope, side, angle, side. We used law of sines here in the middle just to see if it would work, and it did. But otherwise, just plugging and chugging to our calculations. And then, last but not least, we did an application problem of a women's softball field. And this little phrase right here, the pitcher's mound is not halfway between, showed us that it was not a right triangle, so we couldn't just use Pythagorean, we had to use law of cosines. Careful with your calculator. If you have any questions, you can ask me tomorrow. Okay, here we go. Sorry for taking it away, folks. Once again, this is an alternative way of solving for area of a triangle. Now you know 1/2 base times height, what we talked about last section. Sometimes that gets messy, and we don't want to have to do all the geometry if we don't have to. This nifty-difty little formula makes it so we don't even have to really think about geometry. But, as you guys write the formula, these little S's, what do they stand for? Yeah, it's right there. Semi what? Perimeter. And remember, perimeter is the distance around. Area is the area covered inside, right? The interior amount. Perimeter is the outside amount. So it's literally just say, hey, add the three sides. Semi means cut in half. Once again, you guys can tell why we're using calculators, yeah? Because those numbers down below are gross. So how do we find a semi-perimeter? We start there and we say, hey, it's just all three of the sides. The distance around 43 plus 53 plus 72. Cut in half. Mental mathers. Just kidding. You probably already cheated and plugged it in. What did you guys get?
84.
168 cut in half is 84. That's not the answer, that's the S. Then it's as easy as 84 times 84 minus, take them one at a time. Does not matter the order because multiplication is commutative. 84 minus 53, 84 minus 72. Technically, could your calculator handle that? Just put it in. Yeah, of course. But if you like mental math and you want to make it easier to plug in, you can go ahead and subtract each of them. But that's probably not many of you. What would that one be? 41? That one would be 31. That one would be 12. Either way, just make sure your square root is outside of everybody. What do you guys get as your area?
1,131.887 meters squared.
877?
1,100.
Was 877 there?
Yes.
And then why am I putting meters with a squared? 887. Is that better, guys? Yeah, because if you think about area, remember length times width, meters times meters, meters squared, but in ours, we have a triangle, but still.
Units for this.
Yeah, we have meters and meters and meters and meters, meters to the fourth square root ends up being meters. That's not too bad. It's a whole lot nicer than having to do this whole little like 43 thing, and this whole like 53 thing, and then this whole 72 thing. And saying, stink, don't I need the height as well as the base? Have to do some right triangle stuff, it'd just be a mess. It's going to be a lot easier if we can just use Karen's formula. I like Hero's formula, that was an old book that I taught from. Either way. Well done. That wasn't bad, was it? Yeah, right? Not too shabby. Wait a minute. Wait a minute. Whoa.
No.
What's going on?
We're leaving.
We're leaving? You guys are walking out? Having a protest? Or get off the airport? Anyway, we're gonna start just a little bit. Little bit. Don't worry, not a lot. It's literally just this one page, and I'm gonna pull up the homework and let you guys start it. Sound good? Okay. Oh, I might have missed. The one thing I want you to see today, besides getting down this one page of notes so that we are ready to start booking it tomorrow after we check our even answers. Is number one, we have this new thing called a vector. Has two different main pieces that we'll fill in tomorrow. Oh. It'll be more fun if we do it tomorrow. It can represent all sorts of different things, and I should add in one thing right here just to make it, because I'm going to talk about it, so may as well just write it in. Vectors are used in like physics or engineering or navigation. Let's talk about things like force, things like velocity, things like length, which are, by the way, measured in completely different units. So that's interesting. This one mathematical tool is used to talk about many different types of things. Our book is going to always make a vector. Remember in geometry, or we've been talking about geometry, capital letters are angles, lowercase letters are sides. In our book, they say bold letters are vectors, but I'm not going to have you trying to write in bold, number one. And number two, I'm not going to have myself trying to figure out if you wrote in bold. So even though the book is going to write it in bold, not acceptable for you, anytime you see a bold letter representing a vector, you need me to you need to show me this little arrow on top. And make it clear down here, because in the notes I'm going to use bold. I'm going to pretend like I'm your book for a bit. I want you guys to show me a vector, which you guys can do, the little two-sided arrow. Shouldn't say two-sided arrow. An arrow with the top and bottom tail on the right. But actually, to be honest, you look smarter, it seems snazzier, it doesn't run into your letters as much if you just put one tail. No, that doesn't make sense. If you just put one tail, or one side of the tail. And I think that also helps us distinguish between what we're now learning as a vector from question. Where else have you seen, where else have you seen this notation before if you put both sides? It wasn't a segment because that was just a straight with no arrow, right? Array, there you go. Array had a point on one side and had an arrow on the other. However, question, you guys should all be able to answer this. How long did array keep going for? Forever on one side. Here's the struggle. Vectors, stop. Vectors, stop. It's really weird. If you just think about geometry and what you know from geometry. This arrow does not show forever, which is why I try to write it differently, which is why I just do that one little tail that I was talking about. And in like physics and stuff, they only show 1, 2 also. The things I want you to pull away from today in section 6.3, just as we introduced it, that there's this thing called a vector. This mathematical measurement tool. It can talk about many different types of quantities with many different types of units, but not within the same problem. That would give us some issues. The book's gonna say, hey, every time I show a lowercase bold letter, that's a vector. No. We're gonna say we need to show it with an arrow. So every time you write down, or I have a bold letter in my notes, I'm gonna say, no, don't write bold. Did you write your arrow? Did you write your vector on top? And the arrow does not mean going on forever. The arrow means going in a certain direction. Let me show you one more thing. We can start at point P, we can end at point Q. There is another way of talking about the vector. We can also explain it as its initial point and terminal point. Its initial point and its terminal point, kind of like an angle. It does have a beginning and an end. But another way of talking about this is tail and head. You can think the tail is behind, right? So if the arrow's up here, the tail is behind, it's down here. Or if you want to think, you can think about a comet's going this way, where would the tail of the comet be? Behind it, yeah. The tail would be behind it. So we have a terminal point, we have an ending, we have an initial point, we have a terminal point. Initial point's called the tail, terminal point's called the head, and we can talk about vectors either with one single lowercase letter, or we can talk about a vector with its points. Alright, cool kids, I'll stop there. Sound good? Okay. Oh, we can't do that without some inspiration, but we'll get inspiration tomorrow. No inspiration? Probably, there's a very popular cartoon that talks about it. That's part of it. Alright kiddos, let's go ahead and get your spirals out. Let's get that section 6.2 homework written down. As we do that, to see as we look at it, shouldn't take that much space.
No.
I guess it's like that.
No. No.
It's on its own.
I don't want it. Really, Nathan?
Oh, and it's the first dance here.
It's coming. Oh my goodness. Alright, kiddos, you have about what, 10 minutes? That's a good amount of time. Way more than we usually do, right? Here we go. 6-1 and 6-2, whatever you need. Go ahead and grab, oops, sorry, that's right in the way, isn't it? There we go. Go ahead and get what you need. You guys can work for a little bit.